5.1, Identifying Linear Functions. So in Chapter 5, we're going to be working with linear functions. Some of you might have seen linear functions before. But what a linear function is it's a function whose graph is a straight line. You can sometimes identify a linear function by looking for a pattern at a table or a list of ordered pairs. And sometimes you'll see linear equations that are written in what we call standard form, and that is in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0, so a and b cannot be 0. So another way to determine linear functions is if you see an equation written in standard form, like shown here as 3x plus 2y equals 10 in standard form, that's represented as a linear equation. You could have something written in the form as y minus 2 equals 3x, and you could rewrite this in standard form as 3x minus y equals negative 2. Another way that you could determine whether it's linear or not is if you have the form of negative y equals 5x, you could have 5x plus y equals 0. So these are examples of how something can be represented as linear. When it's not linear, that means that the x and y are multiplied, just like this here. They cannot be multiplied. If your x has an exponent other than 1, and maybe your y might have a denominator, these are all examples of something not being linear. So let's look at some examples of identifying linear functions by looking at the graphs. Notice we have a straight line for the first one. We'll call this graph A. We can call the vertical line here graph B. In this curved graph here, graph C. So looking at graph A, that is going to be a linear function because each domain value is paired with exactly one range value, and the graph is forming a straight line. When they form straight lines, that is a linear function. Notice the next one. It is a straight line, but it's a vertical straight line. So actually this graph is not going to be considered a linear function because each domain value is paired with exactly one range value, and the graph forms a line right here. So this, when you look at directly vertical lines like this, they are not considered linear. The next graph we have is this curved one, and this is not a linear function as well because of the curve taking place with this. So this would be yes, this would be no, and this would be no. Let's look here where we have a set of ordered pairs. We have 3, 5, 5, 4, 7, 3, 9, 2, and 11, 1. And they want to know if this satisfies a linear function and explain. Well, looking at the notes previously, we can look to see if there's a pattern taking place with the x values, like 3, 5, 7, and 9. And then we can see if there's any pattern taking place with the y values, 5, 4, 3, and 2, and I skipped here 1. So let's determine if this does satisfy a linear function, and actually the answer to this is yes. The set of ordered pairs satisfies a linear function because there is a constant change of adding 2 in the x, which corresponds in a constant change of a minus 1 in the y. So notice the x's, we're adding 2, and the y's, you are subtracting 1. So since that is a constant pattern going on here, that means that this would form a linear function. The last examples here, it says tell whether each function is linear. If so, graph the function. Well, some of you might have seen too equations written in the form of y equals mx plus b. And for A, that equation is in the form of y equals mx plus b. And so this is a linear form as well. Is this equation written in the form y equals mx plus b a linear form? It is. So the answer to this is yes, this equation is a linear function. So we need to graph these points. So, oops, let me go back. Sorry. Okay, so we want to graph this. So here is a graph. Let me erase my notes here, if I can. They won't let me. But this graph here is representing this equation, y equals 5x minus 9. And I can form a table to help me solve this, so I could plug in 0, 1, and 2 for x into the equation and get my y and then graph the points. So that's an example there. For A, looking at B, we have y equals 2 to the exponent of x. In this example here, this is not a linear function because we have an exponent of x taking place right here. So A would be yes and B would be no. So these are pretty much our notes for 5.1, and you will be doing bookwork with this as well in class.